Hey guys, I will give a quick walkthrough of the reversing FTP challenge as well as the exploiting challenge. Actually, I have no idea what the difference between those two is because I solved both with the same technique. So first of all, again, you can download it, and it turns out to be do I have it here? Yeah, it turns out to be a 64-bit binary. So I put it in Hopper because my IDA version is only for 32-bit. So let's connect to it and see what's happening. So it says here, welcome FTP server. With help you get several commands, and it tells you we have to find a way to log in. So user asks for a password, and then invalid login credentials. Okay, cool. So we want to log in, so the way to go here is to basically look where those strings are invalid login credentials, because from there you will figure out how the login works. So here's the function, and if it basically here, please send, so if you type in user and you got the user, then it says please send password for user. Then there's some weird stuff, and this is the error if you didn't follow it properly. So user, and then you type in something, it says I have to use pass and the password. And then so if it's in here, then it says invalid credentials or logged in. So how do we get logged in? So first of all, here's a string compare with the value blank wall. So we can already assume, okay, that could be the user. And then we have a second check here, which is the password. And the password is checked, like hashed and checked against a certain value. So let's have a look at this function there, which is, here's the compare to that magic value and this call here. And then we have this little function here. So this function, you can already see here that it's looping, and you can see, where is it? Yeah, that I have no idea. Whatever. Wait. So in here you see it's a while loop, and let's copy this and clean this up together. So first of all, arg0 is the input. So var 18 is what comes in. So I call this that's the password that you use. Var 4 is like a magic number. Let's call this magic. And so this just return magic. And 0, and we see here that this gets always incremented by 1, so that's very likely to be the counter, so I. And this is the condition if it breaks, so it takes the password and shifts it forward, and then checks if it's 0, so that's basically checking for end of string. So we can rewrite that as for e equals to 0. So we set 0, we set initialize I with 0. Then we have the condition that is the password with the offset of I is unequal to 0. And then we have the counting up condition, which is I plus. So then we have this magic here. So let's remove the signed extent unnecessary. So this again here, password plus the offset is again just is just password offset, and it takes only a character, so that doesn't matter, like it only takes the certain character, and then it does plus the magic value, shifts the magic value by 5 plus magic. So this is the loop. Cool. So now we have to reverse this. I will not I will show you my solution because it took quite some time, and it's the first time I did this. I use Z3 for this. So Z3 is a theorem solver, or SMT solver, whatever. You can give it some restrictions and it will solve solve it for you. So if you, for example, say the value has to be A has to be bigger than 10 and B has to be smaller than 50 and A minus B has to be 33, and then it finds all possible values for A and all possible combinations of A and B that satisfy this rule. And you can create a rule based out of this here and ask it, can you give me a valid string for that? So, and here's how it works. We have to create this rule set for one test. But before I get into it, one other thing, this was the decompilation of Hopper. IDA's decompilation made this here out of it. So 33 times, this is the magic number. 33 times the magic plus the password instead of like shifting the magic and making plus, which is surprisingly equivalent. It's crazy, but yeah. That's why there are two different ways of doing it over here. Anyway, so we have to build those restrictions, and first of all, we test one character, and one character. We create multiple bit vectors for each character. So password 0 basically to password 5, PW1, PW2, PW3, so we create for every single character of the password. So in this case, we only have one. Then we set the starting condition of this magic number, which is 1505. And then we loop for each character again, which is only one character. We do basically this loop only executed once. We do the magic value. Maybe I should rename this here to magic. So magic is equal to, and then it's here. Let's uncomment this and use this one here instead. That should be the same. So it's basically take the current character 0 plus, and then the magic shifted plus the magic, and assign this to magic. So we basically do the exact same thing, and then we also at the end we say wait, that's the wrong one. This here is the correct one. And at the end we append this to F. So F are all our restrictions, and we say that at the end magic has to be this magic value that you can see here in the code. So the end result of magic has to be this certain value. So here we make the restriction and say magic masked with only 32 bits of magic has to be equal to this value, and then that is true. The other restrictions we have here is we check if each character is ASCII. So we have the restriction that the input has to be between 61 to 7D, 41 to 5A, and 30 to 39. So those are kind of like printable characters. We could probably do, 7A is probably better here. And those are also restrictions, as well as this algorithm will catch the new line when you hit enter. So like behind this password that you enter here, so it's LOL and then a new line because you hit enter. So we also restrict and say the last input has to be a new line. And then we get a set resolver. We add our restrictions to the solver. We check if it's satisfied and if we can find a solution. And then with model we get a possible solution. And then new round. We start a new round now with two characters. Again, we build two input characters here. That's just Z3 syntax. Two input characters. We set the magic value again to the start, and now we do it 2 times this loop and do this calculation, or the equivalent that has a little bit less, a smaller spanning tree. So this one is better how IDA decompiled it. And then we add this restriction to our list of restrictions, which is again the magic value has to be this magic value, and that our characters have to be ASCII and stuff. And then we just let it run. So let's see. Python ftp.py. So apparently donkey is a valid password. So let's try this. Netcat connect there. We say user is blank wall and pass is donkey. Logged in. Cool. So what can we do now? So basically we wanna get a list of files. So I did file a list and it said use port or pass v, and I was confused. Okay, so eventually I typed in pass v and realized, wait, it's listening on this port now. Okay, so I do a connect to there 63007, and then do list again, and then it sent the list over over this open port. Okay, let's do this again. Pass v. Now we listen on. We connect to this new port, and instead of list, we do retrieve of the reverse engineering solution. And it says here connect accept transfer starting, and we found the flag. But if you notice, there's another flag. So so we have to connect again here. Connect again. Pass the well, I don't know if it's a 0 or 1. Logged in. So we do pass v again. We connect to this new port, and now we do retrieve on flag.txt. Invalid character specified. That's new. Wait, what did I do wrong? List. Okay, so do it again. 3294. Retrieve flag.txt. Now it worked. Okay, maybe it has to be that specific order. Always list and then. Anyway, here's the reverse engineering flag, and this is the exploitation flag. 600 points.